A fire alarm system is one of the most critical components of modern fire protection strategy, integrating technology, human behavior, and building infrastructure into a proactive safety mechanism designed to detect, alert, and initiate response against fire-related hazards. At its core, a fire alarm system functions to detect the early signs of fire, be it smoke, heat, or flame, and promptly alert occupants so they can evacuate while initiating emergency protocols such as alerting first responders or activating sprinklers. The sophistication of fire alarm systems has evolved dramatically since their inception, from simple mechanical gongs triggered by manual pulls to complex addressable electronic systems that provide real-time diagnostics, fault detection, and networked communication. The system is composed of 4 essential components: initiating devices, control panel, notification appliances, and power supply. The initiating devices are the sensors of the system and play the most critical role in detecting the fire. These include smoke detectors, photoelectric or ionization type, heat detectors, fixed temperature or rate of rise, flame detectors, manual pull stations, and gas detectors. Photoelectric smoke detectors function by detecting scattered light caused by smoke particles entering a sensing chamber, while ionization detectors measure the disruption of an electric current caused by smoke ions. Heat detectors, on the other hand, react to an increase in temperature or the rate at which the temperature rises. Manual pull stations are human-operated switches usually placed along evacuation routes, allowing building occupants to manually trigger the alarm. These initiating devices are interconnected by wiring or wireless technology and are constantly monitored by the brain of the system, the Fire Alarm Control Panel, FACP. The FACP is the centralized unit that processes information received from initiating devices and determines whether to activate the alarms. It continuously monitors all connected devices for fire conditions, system faults, or tampering. When an initiating device detects abnormal conditions, it sends an electrical signal to the panel. Based on pre-programmed logic, the control panel then triggers the appropriate response. In addressable systems, each device has a unique digital address, allowing the panel to pinpoint the exact location of the alarm, a crucial feature in large buildings or high-risk facilities. This contrasts with conventional systems, where devices are grouped into zones and the panel can only identify the affected zone, not the specific device. Once the control panel confirms a fire condition, it activates the notification appliances, which are the system's output devices used to warn people about the emergency. These include audible alarms like horns and sirens, visual indicators like strobe lights, and voice evacuation systems that broadcast clear spoken instructions. Some systems use tactile devices like vibrating pads for the hearing impaired. The layout and type of notification appliances are carefully planned to ensure all building occupants are reached promptly, even in noisy environments or areas where hearing is impaired. The design must comply with standards such as NFPA 72 and local building codes, ensuring sufficient sound pressure levels and light intensity throughout the facility. Power supply is the final pillar of a fire alarm system. The primary source is typically the building's main electrical power, but every compliant system must also have a reliable secondary or backup power source, usually a sealed lead-acid battery or an uninterruptible power supply, UPS, to keep the system operational for a minimum of 24 hours of standby and 5 minutes of alarm time in the event of a power outage. Larger facilities may also use dedicated emergency generators. Maintaining continuous power is critical because a system failure during a fire event can lead to catastrophic consequences, both in terms of property loss and human life. Fire alarm systems often integrate with other building systems to enhance response and safety. For instance, upon detecting a fire, the system might automatically shut down HVAC systems to prevent the spread of smoke, unlock doors for evacuation, or activate elevators programmed for emergency recall. Some systems are also tied into fire suppression systems like sprinklers or gas-based extinguishing systems, ensuring a seamless transition from detection to suppression. In high-security or critical infrastructure environments, fire alarms may also trigger alerts to remote monitoring stations or emergency control rooms, where staff can coordinate evacuation or initiate contingency plans. Maintenance and testing of fire alarm systems are just as important as their initial installation. Components like smoke detectors and heat sensors are prone to dust, humidity, or mechanical wear, which can reduce their sensitivity or cause false alarms. Therefore, regular inspections are mandated under fire codes and standards such as NFPA 72, which recommend visual inspections, functional testing, and documentation at specified intervals, monthly, quarterly, semi-annually, or annually depending on the system component. Fire drills and alarm response exercises further ensure that the building occupants understand the alarm signals and evacuation procedures, enhancing the real-life effectiveness of the system. False alarms are a major challenge for fire alarm systems. They can be caused by faulty detectors, poor installation, environmental factors, like steam or dust, or even malicious tampering. Repeated false alarms lead to complacency among building occupants and can overwhelm emergency services. Therefore, modern systems are equipped with features like alarm verification, cross-zoning, and adjustable sensitivity to reduce false activations. Alarm verification involves a delay between detection and alarm activation, during which the system checks for confirmation from another device or waits a set time to ensure the threat is real. Cross-zoning requires inputs from two different devices in the same area before the alarm is triggered, minimizing the chance of false positives. Technological advancements have transformed fire alarm systems into smart, integrated safety platforms. Networked fire alarm systems now allow multiple control panels across different buildings to communicate with each other, providing centralized control and event logging. These systems are often connected to building management systems, BMS, enabling facility-wide monitoring from a single interface. Wireless fire alarms are gaining popularity in historical or complex buildings where hardwiring is difficult. IoT-enabled detectors can send real-time data and diagnostics to cloud-based dashboards, alerting facility managers instantly about system faults or environmental changes. Artificial intelligence is also being explored for predictive fire detection and pattern recognition, where systems learn from past data to detect unusual thermal or smoke signatures before they escalate. In terms of regulations, fire alarm systems must comply with national and international standards to ensure proper design, installation, testing, and maintenance. In the United States, NFPA 72, National Fire Alarm and Signaling Code provides the most widely used set of guidelines. In Europe, EN 54 series of standards applies. Local municipalities often have additional fire codes based on occupancy type, building height, use case scenarios, and risk profiles. For instance, a hospital or data center requires more complex and redundant alarm systems than a residential building due to the higher stakes involved. Authorities having jurisdiction, AHJs, review all fire alarm plans and conduct final inspections before occupancy approval is granted. From an economic standpoint, the cost of a fire alarm system can vary significantly depending on the scale, complexity, and technology involved. A small commercial building might install a basic conventional system for under $5,000, while a high-rise or industrial plant could spend hundreds of thousands on a fully integrated addressable system with voice evacuation, graphical interface panels, and third-party monitoring. While expensive, this investment pays for itself in saved lives, reduced insurance costs, and legal compliance. Additionally, integrating fire alarm systems with emergency response plans ensures a coordinated response to real emergencies, minimizing confusion and improving survival rates. In conclusion, fire alarm systems are much more than noise-making boxes. They are intelligent, life-saving networks designed to detect fire at its earliest stage and initiate actions that protect human life, property, and business continuity. Whether it's through a basic smoke detector or an advanced multi-sensor addressable system, the principle remains the same: early detection and timely communication can make all the difference in a fire emergency. Understanding how these systems work empowers individuals to respect, maintain, and respond to alarms correctly, ensuring that these silent guardians remain vigilant in protecting us from one of humanity's oldest and most destructive threats.